So today we're going to talk a little bit about function notation, and this is something that you may have seen before. So let's just review, what is function notation? Well, it's a way of expressing a function, and it gives us some flexibility in the way that we write it. Normally you'll see it written as f of x, which is the same thing as y, but we're saying that x is the argument, and so we're taking that argument and we are using that as the input for the f function, is what that explains to us. So if we look at our examples, we have f of x equals 5x minus 7, and we also have g of x equals negative x squared minus 3x minus 5, and h of x equals negative 2x plus 9. And we want to evaluate the following. So what this is saying is this is my input in the f function, and this is my input in the g function. So I'm going to figure out what those values are, and then I'm going to subtract them. So I'm going to start with the f function, and I'm going to use the green color. So here's my f of x. So I'm going to take negative 3 and I'm going to plug it in where the x is. So f of negative 3 equals 5 times negative 3 minus 7. Well, 5 times negative 3 is negative 15, minus 7 would be negative 22. Then I'm going to use my red for g of negative 2 and figure out what that is. So g of negative 2, if I'm looking here, this is going to review an important little concept that we often forget. So the negative applies to after you square x, because the squared comes first in the order of operations. So we've got negative on the outside, then we're plugging in negative 2 as our argument where that x is, minus 3 times the negative 2, which is our argument, and then minus 5. So first I'm going to square that negative 2, that gives me a positive 4, and then multiply it by a negative, which gives me negative 4. Then I've got plus 6, because negative 3 times negative 2 is positive 6, and then minus 5. So negative 4 plus 6 would be 2, and then 2 minus 5 would be negative 3. So now what we're going to do is we're going to take that f of negative 3, which was negative 22, and then we're going to subtract a negative 3, which technically means we're going to add it. So I have negative 19 as my answer. Okay, so this whole expression right here is equal to negative 19. All right, now that's just a simple plug and chug, and as we look at our other examples, we have something else going on right here. So if I look at this one, this says that my argument is negative 3. So I'm going to take that and I'm going to plug it into the g function. Then once I get a value for that, I'm going to take that value and plug it into the f function. So you work your way inside out. All right, so let's start with the g function. We're going to plug in negative 3. So that is going, I'm going to keep the f on the outside, and then g of negative 3 would be negative times negative 3 squared. Remember that negative is the x, so negative 3 is x. And then minus 3 times negative 3 minus 5, keeping that all in parentheses. And then I've got negative 3 squared is positive 9, times a negative would be negative 9, plus 9, and then minus a 5. These two are going to give me 0, so I'm really evaluating f of negative 5. Now, if I look up here, I'm using that same f function. So when I look at that, I've got 5x minus 7 is f of x. So I am going to say this is equal to 5 times negative 5 minus 7, which would be negative 25